Good morning, students. In this video lecture, we are going to discuss about the mobile ad hoc routing. So first of all, we should know about what is routing. So routing is nothing but just forwarding packet from sender to receiver side. If any node want to communicate with another node, means it will just transfer their packets with the destination address. This process we say that routing. What is the main difference between wired network routing and ad hoc network routing means? First we see about the term asymmetric link. In ad hoc network routing, signal quality is uneven in both directions, but in wired network the signal quality is even for both the directions. Here we use the open environment, so the signal quality is uneven in both the directions. And second, redundant link. Normally in wired network we have a few redundant link will be available, but in ad hoc network we have many redundant link due to the open environment and dynamic topology configuration. And then in interference concern, the wired network having a less interference compared with your ad hoc networking. This is a very high in case of wireless ad hoc networks. And dynamic topology, change in topology is very frequent in ad hoc networks, but in the wired network is a static topology. This is the ad hoc network routing protocol classifications. Normally we have three type of classification in ad hoc routing protocols. First one is proactive, second one is reactive, and third one is hybrid. The other name for proactive routing protocol is table driven routing protocol, and the other name for reactive routing protocol is on demand routing protocol. In table driven routing protocol, the well known routing protocol is DSDV. DSDV means distance source destination vector. And on demand driven routing protocol, the well known routing protocol is ad hoc on demand distance vector, AODV. And in hybrid routing protocol we say that ZRP, zone routing protocol. In our syllabus we are going to discuss about DSDV. So DSDV means nothing but destination sequence distance vector, is a table driven routing protocol method. So this DSDV is enhancement of the distance vector routing protocol of ad hoc networks. In problem for distance vector routing protocol is, in the distance vector routing protocol we need to count to infinite values, and in this disadvantage will be overcome by destination sequence distance vector and sequence number. In this DSDV we use the sequence number. Each routing advertisement comes with a sequence number. This sequence number helps to apply the advertisement in the correct order. And how this destination sequence distance vector will be work means, if the sequence number of the one node in the newly received same as the corresponding sequence number in the routing table, then the metric will be compared and the route with the smallest metric will be used. We will explain with this example. The above figure shows the DSDV example. The first table 1 shows the routing table of the node H6 at one instant. In this instant we see the destination H1, the next to is H4, and the metric is 3, and for destination H2 the next to is H4 and metric is 2, and destination H3 the next to is H4 and metric is 3, and for H4 the next to is H4 and matrix is 1, and H5 next to is H7 matrix is 3, and H6 next to is H6 and matrix is 0, and H7 next to is H7 and matrix is 1, H8 next to is H7 and matrix is 2. Now consider node H4 wants to transmit a packet to node H6 for using this routing table means. Now the H4 wants to communicate with H5 is their destination, and using this H6 as intermediate node means it will give the packet value as shown in the left side diagram. H4 will transmit the next rope value is H6 and destination value is H5 and their data, and this packet will be received by node H6 and it will check the next rope is H6 and destination is H5. So it doesn't open the packet, it just forward the packet to their corresponding destination. Here it will check the next rope is H6 and destination is H5. It match the destination value. The destination H5 is present in the routing table, but it says that the next rope for reaching the destination H5 is H7. So this particular packet will be forwarded to the node H7. So the H6 will be forward the packet with the next rope value of H7 with the destination of H5 with the same data. Now H7 will receive the packet. Now the H7 routing table will show that in H7 the destination is H5 will be matched. So the packet will be given to the H5 node. This H5 node will check the destination address and the destination address is matched. So it will open the packet and receive the data. So this is the how the routing table will be updated. For any instant, each node will advertise their table and the particular table will be checked by nearby nodes. Here is first diagram shows that H7 will be advertised their table, and depends upon this H7 advertised table, H6 will be update their table for their further routing process. Thank you.